Hello guys, welcome back to my YouTube channel. Today I am going to solve problem number 3180, maximum total reward using operations I. Okay, so without any delay, let's get started. So in this problem we have given one integer array reward values of length n representing the values of rewards. Okay, so initially your total reward x is 0. Okay, initially total reward x value is 0 and all the indices are unmarked. You are allowed to perform the following operation any number of times. Okay, so first operation is this one: choose an unmarked index I from the range 0 to n minus 1, and if the reward value is greater than your current total reward. Okay, if the reward value is greater than your current total reward x, then add this reward value to x. Okay, that simply means now my total value of this x will become x is equal to x plus reward values. Okay, and then we have to mark that index. Okay, and in the end we have to return an integer denoting the maximum total reward you can collect by performing the operations optimally. Okay, so now see this problem. Okay, so this is example 1. Okay, so here let's say first initially my x value is 0, right? Initially my x value is 0. Okay, so first can I pick this value? Yes, I can pick this value because this value is greater than my x. Okay, so if I pick this value, okay, so let's mark it as visited. Okay, I have already visited this one. Okay, so now my x value will become 1. Okay, so now can I pick this one? No, I can't pick this one because this value is not greater than my total reward value x, right? Then after this I can just pick this value, right? Because this value 3 is greater than my x. Okay, so if I am going to pick this value, then my x will become x is equal to a previous value plus 3. Okay, so total value now becomes 4. Okay, now it becomes 4. Then can I pick this value? Okay, I can't pick this value because this is smaller than my total x. Okay, total rewards. Okay, so I can just pick these two indices. Okay, this is 0th index and this is second index, right? So during the operations we can choose to mark the indices 0 and 2 in order, and the total reward will be 4, which is maximum. Okay, so 4 is my output. Okay, so here, okay, so this is for example 1. Okay, so now let's move to the example 2. Okay, so here these are the reward values. Okay, so here let's say first I pick this one. Okay, I can pick this one because initially my x is 0. Okay, so when my x is 0 I have picked this value. Okay, 1. So now I mark this as visited and now my x will become 0 plus 1 1. Okay, now after that can I pick this value? Yes, I can pick this value because this 6 is greater than my 1. Yes, right? So here now my x will become 1 plus 6, that is 7, right? My x will become 7. Okay, I have marked it as visited. Can I pick this value 4? No, I can't pick this value 4 because 4 is smaller than 7. Can I pick this 3? No, I can't pick this 3 because this 3 is smaller than 7. Can I pick this 2? No, I can't pick this 2 because this 2 is smaller than 2. Then what is the total value of x that I am getting here? I am getting 7. But here, see, what is my output? My output is 11 here. Okay, but using the same approach that I've explained for example 1, we are getting the value as 7. Okay, so we have to become greedy here. Okay, so what I am going to do here, first I am going to sort this array rewards value. Okay, I am going to sort this array. So let's say after sorting it is going to look like this: 1 2 3 4 and 6. Okay, after sorting. Okay, now see here. Now can I pick this one initially? Initially my x is 0, right? Initially my x value is 0, right? Can I pick this one? Yes, I can pick this one. Okay, so now my x will become 1 and I mark this as visited. Can I pick this 2? Yes, this 2 is greater than my x value. I can pick this. Okay, I have marked it as visited and now my x will become 1 plus 2, that is nothing but 3. Okay, can I pick this 3? No, I can't pick this 3 because this 3 is not greater than my x, right? So I can't pick this. then can I pick this 4? Yes, I can pick this 4 because my 4 is greater than my 3. Yes, I can pick that, right? So let's say I have picked that. So now what is the total result that I'm getting? 3 plus 4, that is 7. Okay, this is what I'm getting here, 7. Then after 7, can I pick this? Can I pick this? No, I can't pick this. Okay, I marked it as visited. Can I pick this? No, I can't pick this, right? Because this value 6 is not greater than my 7. Okay, so here see here again I am getting the output as 7, right? So here every time, first thing is that we have always need to sort our array. Okay, we can't just start from the greatest reward. Okay, initially we have to start from the minimum. Okay, initially. Okay, one point is this one, and after that every time we should maintain two options. Either we need to take it or we need to skip it. Okay, these two options we need to maintain. Okay, okay, now let's solve this using this approach, take it or skip it. Okay, so initially initially let's suppose that I am taking this one. Okay, I am taking this one, and after one, can I pick this 2? Yes, I can pick this 2. Okay, let's suppose I am following this path. Okay, then after 2, can I pick this 3? No, if I take 2 here, then I can't pick 3. Okay, because 1 plus 2 is 3. Okay, so after 2, can I pick 4? I can pick 4 or I can't pick 4. Okay, I have two options, I can pick or can't pick. Okay, so let's say in this case I skip this. Okay, I skip this part, I am not going to pick this. Okay, now I have skipped this. Now can I pick this 6? Yes, I can pick this 6 because this 6 is greater than my 3. Okay, so let's say I have picked this 6. Now what is the total value that I am getting here right now? Okay, see here, 1 plus 2 is 3, 3 plus 6, 9, but 9 is my output? No, 9 is not my output. Okay, 9 is not my output. Okay, so now let's move to the other path. Okay, after 1, can I pick this? Let's suppose after 1 I directly pick this 4. Okay, I pick this 4, and after 4 I pick the 6. Okay, can I do this? Yes, I can't do this. Okay, so first initially my x is 0, that is why I am able to pick this one. Now my x will become 1 here. Then can I pick this 4? Yes, because this 4 is greater than my x. So after this my x will become 5. Okay, now can I pick the 6? Yes, I can pick the 6 because this 6 is greater than my x, which is 5, right? I can pick this. So now in this case, what is the total values, total sum that I am getting? That is nothing but 11, and 11 is my output. Okay, so here every time we have to maintain two options. Okay, either we have to take it or we have to skip it. Okay, this is what we need to check, okay, in this problem. But always we have to start from the minimum element. Okay, minimum element, we can't directly start from the max element. Okay, so that is why sorting is must for this problem. We have to sort our array. Okay, okay, so I hope that you guys are clear. Okay, so I'm going to write the same code whatever I have explained here. Okay, side by side. So okay, so let's move to the approach one part. In this I'm just going to use simple recursion. Okay, so first write few basic things. First let's calculate the length of my rewards value array. Okay, reward values dot length. Okay, this is done. Then after that let's sort it, arrays dot sort this reward value. Now after sorting, here I am just going to call one method, return solve, and in this solve first I am going to start from my index 0, right, and I am passing my array reward values, and I am passing initially my x value is 0, right, so I am passing here x as 0. Okay, now I am going to call this method. Okay, so now let's define this method as well. Okay, so here public int solve. In this solve I am passing my index I am passing this array reward values, and also I am passing the value of x. Okay, this is done. Now inside that, here I have two options, right? Either I have to take it or skip it. Okay, so but before that, let's write one base condition. If my I becomes greater than equal to my value of this rewards value dot length. Okay, so here reward values dot length. Okay, if my I becomes greater than equal to reward values dot length, okay, then we have to simply return 0. And now we have two options, take it or skip it. So let's suppose that I am taking this value. Okay, int take. Okay, so let's initialize it with 0, int take. So now if x value is less than my reward values of I, okay, if my x value is less than my rewards value of I, okay, then in that case I have to update my take as reward values of I plus, okay, so again I have to call this method solve, and now in this solve method my I is going to move one step forward, and I'm just going to pass my array that is nothing but a reward values, and now what is going to be my value of x? My x will become x plus reward values of I. Okay, reward values of I. That's it. Okay, if I'm taking my x, okay, if my x value is less than my reward values dot reward values of I, then simply I can take it now. So if I'm taking it, I have to add this value in take reward values of I plus again call this method. Okay, now this is done. Now after that, if I'm skipping it, so here let's create one variable int skip. If I'm skipping it, okay, again call this method. Now in case of skip, my I is going to be incremented, reward values is going to be incremented, and in x there is not going to be any change. Okay, this is done. That's it. And after that we have to just return the max value. Okay, return math dot max of skip and take. Okay, so here in this problem I am not using any memoization. Okay, I am just using simple recursion. Okay, so now let's try to run the code and see. So see, all the test cases has been accepted, right? All the test cases has been accepted. Okay, so code is very simple. Okay, simple recursion. Now if I submit this code, then see what's going to happen. See here, I am getting this error, time limit exceeded. Okay, so 577 out of 586 test cases passed. Okay, this is done. So you guys are going to say let's use memoization then. Okay, so can I use memoization here? See, the constraints are like this. Reward values I starting from 1 to 2000. Okay, length is this 1 to 2000. Okay, can I use memoization here? Okay, so let's see. Okay. Okay, now I am talking about approach number 2, that is recursion plus memoization. Okay, so here let's create one variable, create one array, right? So here private. Okay, now I am just converting my recursion code including memoization here. Okay, so let's create this variable t. This is done, and here inside that let's define it new. T is equal to new int, and here pass 2001, and here pass 4000. Okay, so here why I am writing 2001 and 4000 here? Okay, so let's see here. So what are the constraints? Okay, so I is from 1 to 2000, so that is why I am passing 2001. Okay, and here values are also from 1 to 2000. Okay, so let's say if one value is x. Okay, so this is the max reward value. Max reward value, let's say, is x. This is the max reward value. Okay, x. Then what is the previous max value before this x? X minus 1. Okay, so this is the max value of reward. Okay, this is the max value of reward. Let's say this value is 2000. Okay, before that I don't want this x. Before that I want to add max value. Okay, without this x. So this is going to be my second max, right? So let's say this value is 199, right? So now let's solve this equation, x plus x minus 1. So it is going to become 2x minus 1. Okay, so my x is here 2000. Okay, 2 into 2000. Okay, x plus x, 2x minus 1. Okay, and here minus 1. So here 4000 minus 1, that is going to be nothing but 3999. Okay, so this is the max value of rewards that I can get at a certain point. Okay, this is a max value. Okay, so let's suppose this is array. There is one array, right, of size 2. Okay, so one size, let's say one size is this 3999. Okay, and one size is 399. Okay, let's say it is 8399. Okay, so if I pick this value, this reward value, okay, 3998, then this is going to become my max. Then can I pick this one? Yes, I can pick this one as well, 399. But here, one second, here size is 2000. Okay, so let's do one thing here. Let's take this 199 and 2000. Can I pick this? Yes, I can pick this 199. After that, can I pick this one? Okay, I'm taking the max values here, 2000. I can pick this one. Yes, I can pick this one. So what is the total value? It is going to become 39999. Okay, 3999. Okay, this is the max value that I can get. Okay, at certain point. Okay, max value. This is going to be the max value. Okay, of the reward. So that is why it is going to be until 0 to 3999. Okay, so I'm going to write here 4000. Then after that, inside this, let's fill my array, this memoization array, 2D array, with minus 1 initially. Int I is equal to 0, I is less than 2001, I plus plus, and here for int j is equal to 0, j is less than 4000, and then j plus plus. Okay, then here just update this t of I of j. I am filling minus 1 in my memoization. Okay, and here I am returning this now math.max script take. Okay, so let's update this value here, t of I of x. Okay, max reward, this one. Okay, t of I of x. Okay, and here just we need to write one thing. If, okay, this is how we do the memoization, right? T of I of x is not equal to minus 1, that simply means that we have already accessed this value. So just I need to update this as return t of I of x. Okay, so now let's run the code and see if there are any code issues. I hope not. So all the test cases has been accepted. Okay, all the test cases has been accepted. Now here, 1 minute. So last time when we submit our code, we get time limit exceeded error, right? So here see, 577 out of 586 test cases passed in approach 1. Now let's submit the code for approach 2 where we used memoization. So let's do that. See, we are again getting time limit exceeded error, but this time only 260 out of 586 test cases passed. and the reason is very simple, because of this memoization array that we are using. Okay, constant size is very large, we can't use memoization here. Okay, so now this is for approach 2. Okay, so now let's move to the final approach. Okay, final approach number 3, in which we are going to use DP. Okay, so now we are going to solve this problem using dynamic programming, bottom-up approach. Okay, so let's take this array as an example. Okay, so let's suppose this is an array given to us in which there are total 3 elements. So first thing that we have to do is sort the array. Okay, so after sorting my array, it is going to look like this: 1, 3 and 6. So now 1 is at 0th index, this 3 is at 1 index, and this 6 is at 2 index. Okay, after sorting. So now after sorting, since this is a bottom approach, okay, so I have to make a 2D array. Okay, I have to make a 2D array here. So in this 2D array, okay, so here this side, these are the different indexes. Okay, I values, I0, 1 and 2, and here in the column side I am filling the max amount of awards that a person can get. Okay, max awards, let's name it as max. Okay, max value of the rewards. Okay, now let's first fill this last values. Okay, all these values. Okay, first, so and this is the max value 6. Okay, so if a person, this is a max rewards that a person can win. Okay, so let's suppose if a person wins 6 award, okay, 6 number of awards, then before that what is the max value that he can win? 5 is the max value, no? If I don't want to include this 6, before 6 this 5 is the second max, right? So in total a person can win 11 medals, right? This is, I have already explained this in approach 2, right? During the constraints. Okay, during the constant, like one constant is 2000 and one is 1999. Okay, then we are going to get max reward value is 3999, right? So same way, so first I am going to fill this value. Okay, initially these values are empty. Okay, so first 6 is the value here, right? 6. So if a person doesn't win any extra award, okay, so here I am filling 6. Now at this position I am writing 6 plus 1 7. Okay, if this person wins 1 extra award, if this person wins 2 extra award, right? 6 plus 2 8. Okay, before 6 let's take that, let's suppose that this person wins 2 awards. Okay, before that I am filling the last values. Okay, last row values. Okay, let's suppose this person wins 6, and before that let's suppose that this person wins 3 values. Okay, before this 6. Here let's suppose this person wins 6, and before that let's suppose that this person wins 6 plus 4 medals. Okay, total 10. Here let's suppose this person wins 6 plus, before that max value is 5, so 11 medals. Okay, so here first thing that I have to do, I have to fill my this DP array like this. Okay, last row. Okay, so here I am starting from 6. Okay, this is 6th. Okay, 6 is at 2 index, this 3 is at 1 index, and this 1 is at 0 index, right? So here 6, and before that if this person doesn't win any award, so 6 only. If 6 and before that let's suppose person win 1 award, 8 here, because 6 and before that let's suppose person wins 2 award, 6 before that let's suppose person win 3 awards, 6 before that let's suppose person wins 4 awards, 6 plus let's suppose previously this person wins 5 awards. Okay, so 11. Now this is done, we have filled all these values 6 7 8 9 10 11. Okay, so now we are going to fill these values. Okay, 9 10 11. Okay, now we have to fill these values. Okay, this circle. Okay, we have to fill all these values starting from this value. Okay, this point. Now here 3. Okay, here 3 initially what is the value here? 3. Okay, 3 initially. Now let's suppose here 3, I am starting from this 3 now, I am checking from this 3 now. After this 3, can a person take this award? Yes, because this value is less than my 6. Okay, 3 value is less than my 6. Okay, after this 3 person can take this award. Okay, so here I am writing 9. Okay, after this 3 person can take this award. Okay, this is done. Then here after 3, okay, in 3 I have added 1, in this 3 I have added this 1. Now total value becomes 4. Now after 4, can I win this award? 6. Yes, I can win this award. Then 4 plus 6 is nothing but 10. Okay, see here. First let's focus on this green color part. Okay, green color part. 3 and person wins this 0. Okay, before that there are no medals, 0 votes. Okay, before that, so in total 3 votes are there, and after that this 3 person can take this reward 6. Yes, he can take this. So what is the max number of rewards that I am getting? 9. Okay, this is clear. Okay, this is how I am feeling 9 here. Now let's focus on this green color part. Okay, this green color part. So here starting is 3. Okay, starting is 3, and here person win this extra 1 before that. So 3 plus 1 is 4 at right now, 4. And after this 4, can a person take this award? 6. 4 plus 6, yes, he can take that, right? So 4 plus 6 becomes 10. This is done. This is how I am feeling this 10 here. Okay, this is done. Now after that, let's focus on this part, 11, how this 11 is coming. Okay, so this value is 3. Okay, and before that, let's suppose the person wins these 2 words. 3 plus 2 is 5, right? 3 plus 2 is 5, and after 5, can person take this value? 6th one, or this 6? Yes, he can take this award because this 6 is greater than 5. So this is how I am feeling here, 11. Okay, so I hope that this is clear how this 11 is coming. Then after that, how this 9 is coming. Okay, so see here person starting from here 3, at this point he wins this 3 award, and previously he also wins these 3 values. Okay, these 3 awards previously also. 3 plus 3 is 6. Then after this 6, can he take this award? No, he can't take this award because 6 is not greater than 6. Okay, he can't take this award. So now at this time, what is going to happen? This person is not going to take the previous awards. Okay, he is not going to consider the previous award. He is just going to pick the max value. What was the max value here? 9. Okay, it is going to take this value only. Okay, so here this is the code part actually. So just don't focus right now mainly. Okay, when I'm going to do the coding, then you can focus on this coding part. But let's understand here that right now I'm going to ignore, because after this 6 I am not going to take this one, right? So here I am just going to write 9. Here also I can't ignore. Okay, I have to ignore 3 plus 4 7. I can't take this. Okay, let's focus on this brown color part. Okay. So initially this person wins 3 awards. After this 3, before this 3, he already won these many awards, 4. Okay, so after that, what can I add this 6? No, I can't add this 6 because this 6 is smaller than my 7. Okay, so I am getting 7, but I need to update the max value here. Okay, I need to update the max value here. So let's not include this 3. Previously he already won this 4. Okay, in this 4 let's add directly the next 6. Okay, 4 plus 6 is 10. This is done. Now see this 11. Okay, this 11 previously at this point of time 3, and previously this person has already won this 5 values. Okay, 5 votes previously. Okay, then 3 plus 5 I am getting 8. Then this person can't win this 6. Okay, can't take this 6 because this 6 is less than 8. Okay, so I am planning here, and don't take this 3. Now instead of this, just add 5 and then add this 6. Okay, so 5 plus 6 is 11. That is why I am adding 11 here. Okay, this is done. This is how I am feeding all these values. Okay, so now this is done. Then after that, let's focus on this part, 10, how I am feeling. Okay, so initially here starting from 1, right? So 1, and previously this person doesn't win any award. Okay, 1 plus 0, so 1. After 1, can I pick these 3? Can I pick this 9? Okay, before that C value, can I pick this 9? Okay, I can pick both 3 and 6, right? After 1. So here I am just going to add 10. Alright. Okay, so here initially 1, and after that 1 we can pick other values, right? We can pick other values, we can pick 3, we can pick 6 as well, right? So from here we have to take the max values. Okay, so here this is the code part. Okay, so I'm going to write the code, okay, for this one. Okay, so let's write the code first. Okay, then I will explain a few more things in the code. So let me revert back the changes. Okay, so here before starting few things that we need to write. Int n is equal to reward values dot length. Okay, this is n, and my max is, I am sorting this now, right? I am sorting this one, so let's sort it as well. Arrays dot sort reward values, and my max is going to be stored at the n-1 index, right? So here I am writing reward values n-1. Okay, this is done. Then take one dp array, 2d array, new int here n, and here we need to write max awards. Okay, this is done. Okay, this is how I am creating an array, right? See, max value 6, that is why total 6 values are there in columns. Okay, this is done. Then we have to run one loop. Okay, and first we are filling the last row, right? So here I am going to run one loop from end. This is done. And then for again one loop, and this loop is going to start from 0, and j is going to be less than my max, and j plus plus. Okay, then after that, if, okay, this is one very simple how first I'm going to fill all these values, all these end values. Okay, 6 7 8 9 10, the last row. So if my I is equal to n-1, then simply I do this dp of I j is equal to j plus reward values of I. Okay, so here j plus reward values of I. Okay, this is done. So this is how we are filling the last row. Okay, 6 7 8 9 10. Okay, this is done. Then in the else part, we are going to check two things. First, if my value of j is less than reward values of I. Okay, if it is less than, okay, j value is less than reward values of I, then we have to perform for few operations, few functions. Okay, and in the else part, if it is not, then I have to simply update my dp of I of j as math dot max of j comma dp of, go to the next row, dpi plus 1 and same j. Okay, let's pick this. Okay, this is clear, right? Now inside this we have to write few things. Okay, so if my j is less than reward values of I, then inside this I have to check one more if condition. If j plus this reward values of I, if j plus this reward values of I is less than my max, okay, if it is less than my max, then I am going to update my dp of I of j as math.max. Okay, and here dp of I plus 1, go to next row, and here column is going to be j plus reward values of I. Okay, this is done. And here just simply go to the next dpi plus 1 and j. Okay, this is going to be my value if my j plus 1, j plus reward values of I is less than max. And in the else part, my dp of I am going to update it as dp of I of j. I'm going to update it as math dot max of j plus, okay, if this j plus rewards value of I is not less than max. Okay, in that case j plus reward values of I, and here same thing, dp of I plus 1, pick the value, okay, in the below column, dp of I plus 1 below row, okay, same column, I plus 1 j. Okay, this is done. Okay, it should be like this. Okay, this is done. And here in the end, where is my for loop ends? Okay, here my for loops ends, and so here we have to just simply return dp of 0 0. Okay, now let's run the code and see if there are any code issues. So there are some code issues, let's fix that. So here I haven't initialized, right, int I. Any other issues? No. Let's run it. So see, all the test cases has been accepted, right? So here we are getting output as 10, right? What is test case? 316. Okay, so let's do one thing. Let me create it. 3 1 and 6. Okay, now let's run it. Our output should be 10, right? Yes, output is 10. Okay, now let's submit it and see if we are getting time limit exceeded error this time or not. So see, all the test cases has been accepted. So our solution beats 100% of users with Java. Actually, I think acceptance rate of this code is very low. I think 16.5k only. Okay, acceptance rate is very low, 26.3%. And seriously, I don't want this problem to be of medium level. It is actually a hard level problem. Okay, because recursion is failing, recursion with memoization is also failing, and in DP also it is taking a lot of time, right? And it's also difficult to understand this DP program, right? So now let's see this coding part. Okay, what we are doing here. Okay, so here this is my example 2. Okay, I think. Okay, so here this is example 2. Okay, so first I want you guys to fill the values, okay, for this one. So first we have to sort this. Okay, after that we have to create one DP array, right? So tell me what is going to be the row, how many rows and how many columns are going to be there. Okay, so tell me. So see here, total elements are there 5, right? So 5 into what is the size of columns? Okay, how many number of columns are there? What is max value? 6. Okay, so this is your one hint. Okay, 5 into 6. So see here, 0 1 2 3 4 5, 0 1 2 3 4. Okay, total 5 rows and total 6 columns, right? So first I want you guys to just pause this video and fill this DP array. Okay, fill this DP2D array. Okay, so first thing is that we have to fill all these last values. Okay, so initially at this fourth index we have this 6, so 6 7 8 9 10 11. Okay, at this fourth index we have 6 now. Then at this 3 index we have this 4. Okay, so if we have 4, okay, here 4 is there. Okay, if there is 4 and right now previously we haven't won any vote. Okay, 0, so 4 is there. Then after 4 can I add this 6? Yes, I can add this 6, so I am getting here 10. Okay, so here total votes is 4. Then after that previously we have already won this one vote, so total is 5. After 5 can I include this 6? Yes, I can include that, so that is why I am filling here 11. See here, now previously we have 4, then previously we have 2 votes. Okay, this time 4, then it is become 6. After 6 can I take this 6? No, I can't take this 6. Okay, so now what I'm going to do, So here instead of this 4, okay, I'm just going to add 2 plus 6. Okay, 2 plus 6, 8. I'm not going to add this one. So here I'm getting 8. Okay, so I can simply pick this one. Okay, so this is my coding part here. So if j plus reward values is less than max, then I am updating my dp of ij like this. Okay, dp of ij like this. Okay, so here I am applying this dp of ij. Okay, here apply this formula. Okay, dp of I of j is equal to I is 3. Okay, dp of 3 and j is 0. dp of 3 of 0 is equal to j is 0. 0 is less than 4 rewards values of I, this value. Yes, then 0 plus this rewards value of I, 0 plus 4 is less than max. Yes, 4 is less than my max. Max is nothing but 6. Okay, so max I am fixing here now, max reward values of n minus 1. Okay, 4 is less than 6, then I am updating this dp of I of j. Okay, this one. So here dp of 3 of 0 is equal to total max of this one. dp of I plus 1 is nothing but 4, and j plus rewards value 0 plus 4 is 4. Okay, dp of 4 of 4. So what is dp of 4 4? 4 is nothing but 10. Okay, max value here this 10, and that is this one, dp of I plus 1 way 1 plus j. Okay, so simply means this value, so 10 out of 6, which is max 10. Okay, so simply here I am adding this. Okay, so we have 4 already, right? We have 4 already. Okay, so we have 4 words already here. Okay, 4 and 6, 10. Okay, so this is how we are going to fill, and in the end we have to return this value. Okay, so just debug this, okay, the code with, and try to fill this dp array. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.